And so we either build the Terrafab or we don't have the chips. And we need the chips, so we're going to build the Terrafab.
As of early July, Elon Musk's net worth was estimated to be between $920 billion and $950 billion. Following the merger of xAI with SpaceX alongside Tesla, Musk is preparing to spend as much as $122 billion for one purpose: securing control over the future of artificial intelligence through a massive semiconductor superfactory. To put that number into perspective, $122 billion is far larger than most people realize. It's roughly equal to, or even slightly greater than, the entire lifetime net worth accumulated by Bill Gates and nearly matches the peak fortune of AI powerhouse Jensen Huang. It may sound almost unbelievable, but according to reports from CNBC and several other news outlets, Terrafab is expected to cost between $119 billion and $122 billion once fully built. If those estimates prove accurate, this won't be just another chip manufacturing facility. It could reshape the global technology landscape. So what exactly will happen inside Terrafab? Why does it require such an enormous investment? And just how risky is this project really? What you're about to hear may shock you. Love him or loathe him, one thing keeps happening. Elon Musk makes people look twice. His outrageous claims and headline-grabbing comments spark endless criticism, but while everyone's arguing, he's quietly building an industrial empire on a scale few thought possible. From giant EV factories spanning continents to lithium refineries, battery megaplants, massive energy storage systems, the world's largest charging network, and now the Terrafab chip manufacturing facility, the sheer scope of what he's creating is difficult to ignore. Terrafab is a semiconductor megafactory project so massive that it makes Tesla's Gigafactory Texas look like a neighborhood lemonade stand. The project brings together Tesla, SpaceX, xAI, and Intel under one enormous roof in Texas with an ambitious goal: producing roughly 50 times the world's current semiconductor output. But Terrafab isn't just another chip factory. It is designed to manufacture logic chips, high-bandwidth memory, and advanced chip packaging technologies, all in a single location. Instead of shipping partially processed silicon across 3 continents before it becomes a finished chip, every stage of production takes place under one roof. It may be hard to believe, but the proposed Terrafab complex is expected to span 100 million square feet, an area roughly equivalent to 1,700 football fields. Construction permit applications have already been filed in Grimes County, Texas, although the project is still in its early planning stages. Terrafab aims to deliver 1 terawatt of AI computing capacity per year while producing between 100 billion and 200 billion custom chips annually. In April, Intel officially joined the Terrafab project. The reality is that Tesla has little experience operating semiconductor fabrication plants, so the company recruited Gary Zhang, a manufacturing veteran with 17 years of experience at Intel, to serve as director of Terrafab, the first officially appointed leadership position for the project. Hiring the manager of Intel's 18A manufacturing operations directly into the role of director of Terrafab sends a clear signal. Tesla is steadily building its semiconductor manufacturing capabilities by bringing in Intel's most experienced talent. That strategy could ultimately give Terrafab access to cutting-edge 14A process technology, one of the most advanced chip manufacturing nodes the industry is racing to achieve. Most people see Tesla and immediately think electric cars, SpaceX, rockets and Starship, xAI, Grok, and the race to dominate artificial intelligence. But that's only the surface. The deeper you dig into Elon Musk's empire, the more one surprising truth becomes impossible to ignore. Every one of these companies is powered by the same critical resource: computing power. Right now, there are 2 projects Elon Musk is devoting the vast majority of his time to at Tesla, reportedly spending at least 60 hours a week on them: Optimus and Robotaxi. Both projects have reached their final stages and are essentially waiting to enter mass production. The biggest bottleneck isn't the technology itself, it's the supply of AI chips. Tesla's suppliers simply can't deliver enough of them. A modern Tesla is no longer just an electric car with a battery and motors. Nearly every Tesla on the road today is equipped with autopilot and full self-driving. These systems rely on powerful onboard processors capable of analyzing camera feeds in real time, detecting vehicles, pedestrians, traffic signs, lane markings, and countless other driving scenarios. All of that computing power is packed into a single AI-5 chip, which was showcased during the Terrafab launch event. In recent months, a small fleet of cybercab robotaxis has been operating impressively on public roads in the United States. Elon Musk has stated that by the end of this year, Tesla plans to deploy large fleets of fully autonomous vehicles that require no human driver at all. To make that vision a reality at scale, demand for AI chips will grow exponentially. And if you think self-driving cars are demanding, that's nothing compared to what comes next. Optimus robot. A humanoid robot doesn't just recognize the world around it, it has to make sense of it in real time. It must identify objects, stay perfectly balanced, coordinate dozens of moving joints at once, respond naturally to people, and adapt instantly to an endless stream of unpredictable situations. That level of intelligence comes at an enormous computational cost. In fact, many experts believe mass-market humanoid robots will require far more computing power than smartphones or laptops ever needed, and that's only part of the equation. Then there's SpaceX and xAI. At first, the idea that a rocket company would need cutting-edge AI chips sounds almost absurd. But that assumption falls apart the moment you remember one thing. SpaceX isn't just building rockets anymore, it's running Starlink. According to sources, Elon Musk wants to transform Starlink from a simple satellite internet system into a flying supercomputer with a massive AI data center in orbit, running AI reasoning directly in space. And to do that, SpaceX will need a special type of chip. A chip unprecedented in the history of the semiconductor industry. We will discuss this chip in more detail later. Then comes xAI, where the demand for computing power reaches an entirely different level. Training today's most advanced AI models isn't just about writing better code anymore. It takes an almost unimaginable number of GPUs and an enormous computing infrastructure to make it all work. That's why the world's biggest tech companies are scrambling to lock in chip supplies from NVIDIA, TSMC, and Samsung. Based on Musk's comments about Terrafab, he believes the world's entire AI chip manufacturing capacity today might satisfy only about 2% of what Tesla, SpaceX, and xAI could eventually require. If that estimate is anywhere close to reality, the conversation changes completely. This is no longer about ordering more chips or signing bigger supply contracts. It's about a much deeper problem. The global semiconductor industry itself may not be capable of expanding fast enough to support the scale of Musk's AI vision. Elon Musk has hinted that Terrafab could eventually reach something on the order of 1 terawatt of computing capacity every year. At first, that number sounds so outrageous that many people assume they must have heard it wrong. But the scale becomes even more staggering when you put it into context. The entire U.S. power grid is often described as averaging around 0.5 terawatts of electrical power. So if computing becomes the electricity of the AI era, Musk is talking about building digital horsepower on a scale that popular comparisons place at roughly twice that of America's entire power system. And the numbers only get wilder. If each AI chip consumes around 250 watts, reaching 1 terawatt of compute could require producing nearly 4 billion chips every year. At that point, you're no longer looking at the ambitions of a car company, you're looking at the foundation of a global industrial machine. We all know Tesla is good at building world-class EVs, SpaceX knows how to build rockets that reach orbit. But manufacturing cutting-edge semiconductors is an entirely different game. A 2-nanometer chip fab has almost nothing in common with an automotive production line. It demands ultra-clean environments, EUV lithography systems worth hundreds of millions of dollars, atomic-scale precision, and manufacturing yields so high that even the smallest mistake can erase billions in investment. One microscopic defect can ruin an entire batch of wafers. That's exactly why Intel brings something Elon Musk can't simply accelerate with money alone. Decades of hard-earned experience running some of the world's most advanced semiconductor fabs. And at the heart of the Terrafab vision are 2 flagship chip families, each built to support one of Musk's biggest long-term ambitions. The first is a new generation of AI processors, the computational brains behind full self-driving, Robotaxi, and the Optimus humanoid robot. According to Elon Musk's roadmap unveiled at the Terrafab event, the AI-5 generation is expected to begin its initial ramp in 2026 before moving into full-scale production the following year. But AI-5 is only the beginning. With AI-6 and AI-7 expected to follow in rapid succession, Terrafab could drive an enormous leap in computing performance, pushing far beyond anything found in Tesla's current generation of AI hardware. Yet the story doesn't stop on Earth. While one family of chips powers autonomous cars and humanoid robots, another is being built for an entirely different battlefield: space. The D3 lineup is designed to become the technological backbone of Starlink, where every chip must survive relentless radiation, violent temperature extremes, and the unforgiving challenge of operating in the vacuum of space. Together, these two chip families represent two radically different engineering philosophies. One is optimized for split-second decisions, adaptability, and safety in constantly changing human environments. The other is built for absolute reliability, bringing AI computing power directly into orbit. While Terrafab's Earth-based AI chips are built for lightning-fast decision-making, real-time adaptability, and safe interaction with people, the D3 lineup follows a completely different philosophy. Its mission is endurance above everything else, delivering powerful AI computing in one of the most unforgiving environments ever engineered for: space. And the scale of that ambition is just as staggering as the technology itself. Based on the current roadmap, Terrafab could launch with a production capacity of around 100,000 wafers per month, then expand over time to an astonishing 1 million wafers every month. To appreciate how enormous that is, consider this. By some common comparisons, that level of output would approach roughly 70% of TSMC's current manufacturing capacity. From the very beginning, one question has overshadowed the entire Terrafab project. How can Elon Musk build a world-class chip factory when neither he nor any of his companies has ever operated one? And that's not a small hurdle. Manufacturing advanced semiconductors is widely considered far more demanding than building batteries. A leading-edge chip fab is far more than a massive building packed with expensive machines. It requires ultra-clean environments, EUV lithography systems worth hundreds of millions of dollars each, an incredibly sophisticated chemical supply chain, world-class engineering talent, and manufacturing precision measured at the atomic scale. One tiny error can destroy an entire batch of wafers. Even industry giants like Intel and Samsung spent years refining their most advanced production lines before reaching high yields. To be fair, this isn't the first time Tesla has gone after an industry everyone else thought was too difficult to master. When battery production became the biggest obstacle to scaling electric vehicles, Tesla chose a different path. Instead of depending on suppliers indefinitely, it partnered with Panasonic, absorbed years of manufacturing expertise, expanded production at an aggressive pace, and ultimately developed its own technologies, including the 4680 battery. That decision became one of Tesla's biggest competitive advantages, helping it pull ahead of many traditional automakers in the EV race. But semiconductors are an entirely different challenge. Building advanced chips is on another level altogether. That's why so many analysts see Terrafab not as just another ambitious project, but as one of the biggest and riskiest bets Elon Musk has ever made. And that's the end, for now. If this video stole a few minutes of your day in the best possible way, show that like button who's boss and subscribe. More wild stories are already on the way.